one side for each source. It's just one because we have one person to assign for each of the source. And for the destination or the demand side, we have just only one as well because each job requires just only one person to do. Right? So that would be the assignment that we can build as the transportation problem. And again, the objective of the assignment problem is to minimize the total cost, minimize the total time, something like that. So it's minimization problem. Okay. So in real world, we can assign people to the job, assign machine to do the task, assign time to make the production of the product. So and so on. And it's not just the mandatory that we're gonna assign people. We can assign things to another thing, something like that. But for in our class, I'm gonna use the example of assign people to do the project. So this is the requirement for doing the model for assignment problem. Right? First thing is that the number of assignees or number of people and the number of the job or the task have to be equal. So this is the first assumption. So yes, if it's unequal, it's going to be a special case. But for the method that we're going to study right now, the basics one, right? The method of assignment or the Hungarian method, we require that number of people and number of jobs have to be equal. Right? And we allow one assignee or one people to do just only one task. And each task or each job is to be performed by only one person. The total cost that happens for the assignment problem is going to be the combination of the cost of each person to perform each job and sum up together. The objective is to minimize the total cost. So this is the very rough information about the assignment. This slide shows you about how can we model using linear programming for the assignment problem. So let's say that we have the decision variable to be xij. Right, xij, and it's going to be like the binary variable. The binary variable means it's going to have the value just with 0 or 1. 0 is mean not assigned, 1 is mean you're going to assign. So xij means you assign assignee j to do the task, assignee I to do task j. So then cij is going to be the cost associated with you assigning I to do the task j. Right? So then the objective functions, you need to sum up all j and all I of the multiplication of cost and the decision variable. The constraints can be two groups. Right? The first one is about each assignee or each person can perform just one task or one job. And another group is that each task or each job can be performed by only one person. Right? And the variable needs to be binary variable 0 or 1. Okay. So this is the way that we model the assignment problem if you would like to use the linear programming. Okay. But anyway, today we're going to use another method that will be the assignment method we call Hungarian method. Right? And the QM formula also so very easy. Right? So you can go to QM and select module assignment, and then just based on the common sense, you just fill in the cost. And that's it. QuickSort is going to provide all things for you. So this is the step of assignment method, right? We have 2 or 3 steps, right? And as usual, you can read by your own, but I'm going to explain based on the example that will be easier to understand for you guys. So I'm going to use this example, that very small example that actually you have no need to using the assignment method, but I'm going to use this for this problem. This is a very small problem is regard to the 3-person John, Linda, and Smith. All these 3 persons, we're going to assign them to do the project A, B, and C. And the number, you can see this is the table for assignment, right? Just a bit line, that's right, matrix. And the value in the table, right, is about the cost of assign each person to do each project. For example, if you assign John to do project A, you pay $11, something like that. Linda to project B, you pay $10. Okay. So this is our problem. So how can we assign them to each project in order to have the minimum total cost? So the assignment problem involves about this. right? Assign this 3 person to this 3 project. So firstly, you can see that we have 3 person or 3 assignee and 3 project or 3 tasks. So it needs to be equal, right? And the second thing is that for doing the assignment, we're gonna start with what we call the row reduction. Row reduction. Row reduction is what? Okay, you can see that based on the problem. The row reduction is that we're looking for the lowest value for each row. So in this case, for example, the first row, the lowest one is 6, the second one is 8, and the last one is 7. To perform the row reduction, we then are using each lowest value for each row, right? Subtracting from all the value, right? Based on the row. For example, the first row, we're going to use 6, subtracting from 11, from 14, and from itself. So then it's going to change to 5, 8, and 0. The second row for the row reduction, then we're using 8, subtracting from itself, from 10, from 11. So then you're going to have 0, 2, and 3. And the last row, the lowest value is 7. We then using 7, subtracting from 9, from 11, from itself, we're going to have like a 2, 5, and 0. So the value in this table that you see here, this is the result from the row reduction. This is the result from the row reduction. And I'm pretty sure that you can guess what next, right? If we do the row reduction, the next step should be the column reduction. And it's going to apply the same concept. That we're looking for the lowest value for each column. But since the first and the third column, the lowest value for each of them is 0. So that if you do the column reduction for the first column and the third column, it's going to provide the same value, right? So we look at the second column, the lowest one is 2. Then for column reduction, you're using 2, subtracting from 8, from itself, and from 5. Okay, so finally, after you do the column reduction, you're going to have this result. Okay, this is a table to show you about the result of assignment method after you perform the row reduction and then followed by the column reduction. Okay, so this is the first 2 steps, quite very easy. Okay, but be careful, just like last week I said, assignment problem is not difficult. This is the most easiest one. And it would say very, very easy for you for the final exam. So we support that you're getting the full score for this problem. But normally students have a lot of mistakes based on, again, write down the wrong number or duplicate the wrong value from table to table. Okay? And it's difficult for me to grading or marking the score, both transportation and assignment. If you can do it, you get the full score. It's very easy for me. If you cannot do it, right, just 0 is easy for me as well. But if you do it and you finish and it's not correct, so I need to find out what happened. This is difficult for me. I need to investigate. So what happened from step by step and very difficult. And sometimes I see that every step is correct, all correct, but why the answer is not true. I find out that okay, since the first table you write down the wrong number. Okay, so from the problem, something like that. So please be careful about that. Okay, we have finished the first 2 steps. Okay, row reduction and then column reduction. The third step is that very carefully listen here. The third step is that we need to drawing the line, vertical or horizontal only, right? Not diagonal. To pass all the 0 value in the table. But we have to use the minimum number of lines. For example, in this case, okay, I have to draw the line vertical and horizontal using the minimum number of lines to pass all the 0 value in the table. I didn't say anything else. I said just vertical or horizontal and use the minimum line to pass 0 value in the table. So the pattern that you're gonna draw in may be different. It's okay. We don't care. Okay, so but in this case, since it's very small problem, so if I would like to draw the line past all the 0 value using the very, very minimum line, I can draw just only one pattern, right? So I can draw using 2 lines, right? 2 lines. And then after you draw the line, you're gonna checking with the number of row column. Remember, number of assignee and tasks have to be equally, or I would say row and column have to be equal. So in this case, we check the number of line with number of row or column. If all of them, right, the line, number of line and number of row or column are equal, you stop, you reach the optimal solution. If the number of line that you have less than the number of row or column, you are not reaching the optimal solution yet. You need to go to the further step, that would be the modify step. But if you have the number of line more than the number of row or column, so you did it wrong for sure. It's impossible, right? Because the worst case that you're gonna draw in the line, the worst pattern, you're going to, follow all column or all row, right? And then all the line gonna pass all number in the table, right? So there's no way that finally when you're drawing the line, you're gonna have the number of line more than number of row or column. But it can happen as you mistake in some case that we have a bigger problem, such as you have 8 by 8 matrix. Sometimes you confuse, right? And you drawing the line more than the number of row or column. So in this case, back to our problem. Now drawing the line past zero value in the table. I'm using just 2 lines minimum, but I have 3 rows and 3 columns, right? So the number of lines is less than row or column. So it means that I'm not getting the optimal solution yet. I need to modify. Okay, and the way we modify is that we're gonna looking at the value that is not covered by the line. The value is not having line pass through it. In this case, we have 5, 6, 3, and 2. We're looking the lowest value that is not covered by the line. That would be 2. This is the lowest value that we have no line pass through it. The lowest one is 2. So we do the circle around this number. So then, in this case, I do circle around 2. And then I'm going to use this value, subtracting from all the value that is not have the line pass through, and adding at the intersection of the line. So for example, it means in this case, I'm using 2, subtracting from 5, so this one going to change to 3. This one going to change to 4. This one going to change to 1. And this cell going to change to 0. And then I'm going to use 2 adding to this position of the intersection is going to change from 3 to 5. Okay, so this is the way that we modify. Okay. If you don't have the line, intersection line, no need to add. So in this case, after we modify, we're going to have this table. Right. Then the process is we start again. We go back to the previous step that we're going to drawing the line again, using the very small number of lines that possible in order to pass the 0 value in the table. In this case, you can see that finally the lowest or the small number of lines that possible that I'm going to draw to pass 0 value in the table is just 3. And we have 3 rows and 3 columns, right? So both are equal. So now I'm reaching the optimal solution. Okay. And look at this. Maybe some of you might be curious that, Ajahn, why not be drawing the line something like this? 1, 2, and 3, or also 3. This you can. Right? The pattern is vary. The condition that we require just you using the number of lines to pass 0 value in the table. You might draw 3 consecutive lines, something like this. That's okay. As long as you're using the very minimum number of lines. So in this case, I have 3 lines and we have 3 row columns. What are equal? So this is the optimal solution. And the way that we know about the answer is that we're going to look at the positioning of 0 value in the table. So this is the position of the 0 value in the table. And the way that we're going to specify the answer is that we're going to consider 1 by 1, each row and each column. Okay, if you have the different pattern of drawing the line, you might have the different 0 position. That's okay. Because final, after we specify the answer, it's going to have the same. Okay, and sometimes you do it and maybe one assignee don't have any 0 value to specify that what task or project that we're going to assign. You can know automatically because if you have the only one person left, so that project that you have that's going to be the project that belongs to that person. For example, in this case, we consider one by one each row and each column. If I consider each row first, so it means that the first row you can see 0, right? For John is at C, right? So it means John can do project C. For the second row, Linda can do A and B, right? Linda can do A or B. Linda can do. For Smith, can do project A and project C, right? But if we consider in the vertical or the column direction, project A can be performed by Linda or Smith, right? Project B only Linda, and project C John or Smith. So when we consider one by one from each row and column, so finally in this case we can know that John should go to C, and Linda go to B, right? And Smith go to A. And based on the problem, if John C, Linda B, Smith A, you can have the total cost is 25. And since this is the very small problem, as I mentioned that we might not using this method to solve for it. You can just try and error, you can getting the result as well, the same one. But I just recheck that okay, if I just try and error in every case that possible for this problem. Finally, Smith A, Linda B, and John C provide the lowest cost. The same result as the assignment work method. Okay, so this is the assignment, right? We finished. We done. จบแล้ว Yes.
ยังไม่จบครับมีคำถาม how do you know, can you explain again how to know where to draw the lines?
So there is no rule. You just drawing the line, but using minimum number of line that has 0 value.
So
For example,
page 15 now.
Page
this one, yeah.
page yeah, why can't we draw a line down A, a line down B, a line down C, and a line across
because you're using 4 lines and you just 2. I just 2 lines and I pass all 0 value. I just use 2 lines.
So it's the minimum number of lines required to get all 0 values.
Yeah.
Gotcha.
So, but in some cases, you have the different pattern to draw the line. If you have a bigger problem, that's okay, as long as you have the same minimum number of lines that you have to use.
Okay, so
Yeah. By the way, yes, we finished, but I'm going to go to a little bit further. So if this problem, I'm trying to draw the diagram, right, to show the overall picture, just like the transportation last week. So assigning a person, John Linda Smith, is you can look at like the sources of the factory, remember? And this is like the capacity, we have 1 person. And on the other side, this is the project A, B, and C, you can think like the warehouse, that we have the demand 1 as well, because we need just 1 person to do. The arrow is like the option that possible, right, to assign each person to each project. And the number above the arrow is about the cost of that option. So then we can look at this diagram and it's very similar to the transportation problem. So if I would like to apply linear programming based on that diagram, this is going to be the model for linear programming. And as I mentioned that the requirement is that the decision variable x needs to be binary 0 or 1. Okay. If you look at the constraint, you can see x John A plus x John B plus x John C equal to 1. So it means John can do just 1 project. Or x John A plus x Linda A plus x Smith A equal to 1. So it means that project A can be performed by only 1 person. Right? So this is the example of the constraint. Okay, so we want and require that each assignee can do just 1 job. And on another side, each job can be performed by only 1 person. Okay, so this is a linear programming if you would like to solve. Okay. But anyway, as usual, that is a small problem, and there is something else more than that, such as the special case. So I'm going to show you the 5 or 6 special case of the assignment. And the concept is very similar to the transportation problem. We do the same way, very similar for last just like last week. For example, look at the first special case. The first special case is about the case that some assignee, right, cannot be able to perform some specific tasks. For example, in this case, if I use the same problems, but I have one more condition that John cannot perform project C because maybe they have like a problem with the team member of project C, something like that. So we cannot assign John to project C. So then the problem becomes a special case because you cannot assign John to C, right? So the way that we're gonna solve for this special case is just like the transportation that we have two approaches. The first approach that is the one that I'm showing you in the slide, because the problem of the assignments and the transportation is similar in the case that we have the objective to minimization, right? To do the minimization. So in this case, if you cannot or if you don't want assign John to project C, you just change the cost associated of assigning John to C to be the very big value that's significant enough. For example, you can change it to 100, 200 in this case, but for me I change to infinity, let's say. And then you're doing the same step. For example, I've changed from the cost of John doing project C to be infinity, and then I'm doing the same step as usual, starting with the row reduction. So this is the result of the row reduction, right? The lowest value for each row, subtracting from all the values. And then I'm doing the column reduction, and this is the result from the column reduction. After that, I have to draw the line from this. So you can see that the minimum number of lines that we can apply in order to pass zero value in the table is just 3, right? Or this pattern. You cannot, you can, using other patterns such as 3 lines vertically or horizontally, that's okay, the same, right? So I have 3 lines and I have 3 rows and 3 columns, so I'm basically optimal solution. I'm looking at the position of 0 value, and then based on the analysis for each row and each column, I can know that John go to A, Linda go to B, and Sally go to C. Okay, so this is the first approach. If you have the condition that you cannot assign someone to do some project, you can just change the cost to be the very big value and do the same step. Another approach, just like last week that I told you that if you don't want to change the cost, you might, using the pen to marking star or X to that cell. And in every step of your calculation, we are not involve that cell. Right? We're gonna ignore that cell forever for our calculation. Okay, so this is another approach, right? Just marking that cell, and in every step, we will not use that cell, right? No matter what row or column or do another thing, we just ignore that cell. Okay, so this is another approach. The second special case is that the case that you have the number of assignees and number of tasks unequal. For example, if you have number of assignees more than number of tasks on number of projects. So last week we know that if demand is not equal to supply, you just develop the dummy row, dummy column, right? This is the same concept. For example, if I have 4 persons here, John, Linda, Smith, and Dave, but I have just only 3 projects, project A, B, and C. So the number of project and number of person is not equal. So in order to solve it, I need to make it equally. So then I'm adding one more project. It's called dummy project, but actually the dummy project is not exist, right? So the cost I'm using 0 for all. And then you're doing the same step. So in this case, if you add dummy column just like this, so when you do the first step, row reduction, you can have this table because the lowest number is 0 for each row. Okay. And again, if you have the case that the number of tasks more than the number of assignees, right? So you need to do it like the dummy row and all the costs to be 0. And again, when you start with the row reduction, followed by the column reduction is equal to the row reduction because the lowest value for each column is 0. Okay. So we don't care that is equal or unequal. If unequal, you just develop the dummy. One thing that is different from the transportation because based on the transportation problem, you develop just one dummy row or column, right? But you change the capacity or you change the demand. But in this case, let's say if they have 5 persons, John, Linda, Smith, Dave, and Joe, let's say, but you have just 3 projects, you need to have 2 dummy columns. Okay? Dummy 1 and dummy 2, both have 0. Or you have 5 projects, let's say project A, B, C, D, E, but you have just 3 assignees. You need to add 2 more for the assignee to be dummy 1, dummy 2, right? The value cost of all 0 as well. Okay, so this is the way that we're dealing with the unequal assignee and task. Okay, and the last one for the special case that we can see is about the maximization. So we're using the same concept as the transportation last week because if you have the maximization, but our method that we studied so far is for minimization. You need to change maximization to be the minimization problem first by using the concept of opportunity cost. So then what we do is just using the biggest value in the table that represented for your profit maybe or your rating, right? Or your score, rating score or performance score or something like that. And then use that number minus all the value in the table. For example, based on our very first table here, let's say that the value in the table is about the rating, okay? Rating, right? We want to make the highest rating. So the highest value is 14. So then we change the maximization to be minimization by using 14 minus all the value in the table, right? And then you just follow the very simple step: row reduction, column reduction, drawing the line, modify, something like that. Okay, so this is the way that we're dealing with the special case. Okay, but okay, let's practice one more problem. Okay, before we go to another example in the Microsoft worksheet. So let's see this example. I have the example of 5 jobs and 5 machines. Let's say that the number in the table is about the time that required for each job to do from each machine in minutes. Okay. So our objective is try to find that how can we assign this 5 jobs to each machine in order to have the minimum time, right? So let's say that we start with the row reduction. So then I'm doing the circle of the lowest value for each row. Okay, this is the lowest value for each row. And then I'm going to use this value subtracting from all the value in that row. Okay, so then the result is going to be like this. This is the result from the row reduction. Then I'm trying to find the lowest value for each column. Since the first, the second, and the fourth column, the lowest value is 0. So when you perform the column reduction, you can have the same value. So then I'm doing the circle just with the third and the fifth columns. And then I'm using that number subtracting from all the value in the same column. So I have the result, right, from the column reduction. And now everyone please pay attention and look at this screen. And then can you draw in the line, right, past 0 value in table, and can you tell me that how many lines that you use for past 0 value in the table? How many lines? Do not look at the sheet, look at the screen. Just practice. Yes, 5. right? 5 and B5 have 5 rows and 5 columns, right? So it's equally, so we done. And this is the result that, okay, finally we assign job E to machine 1, job D dot to machine 2, job C to machine 4, job B to machine 5, and job A to machine 3. Okay, we done. That's it. So up to this point, okay, I think the concept is very clear. Nothing much. Row reduction, column reduction, drawing the line, checking with the number of row column. If you have both equal, so you done. If you have it's unequal, right, you modify and then you go back to drawing the line again. We do again and again until we reach the optimal solution. But I believe that some of you might be curious one question that why not we start with the column reduction first? Why do we need to start with row first? So the answer is yes, you can start with the column reduction and then followed by row as well. You can do that way. But yeah.
I have a question. Why can we draw the line through C instead of like the horizontal line?
Yeah, you can.
So that will make the 5 and there will be
Yes, correctly. As I mentioned that we don't care about the pattern. You might have the different pattern of drawing the line. But we want the minimum number of lines that you apply to pass zero value with the table. So if your friend asked that question, so she just changed, right, to drawing the line also on the job C, she's still getting 5 lines. It's okay, right, it's correct. So you can start with column reduction and then followed by row. But since I'm teach you to drawing, you apply row first. So when you're doing exam, please doing the row reduction before column. So if you don't do that, I might confuse when you are marking the exam. You know, this one starting with row, another person starting with column. You know, so. So you can start either way, row first or column first, but this is the deal for us. Start with row reduction first. Okay, so let's make it easy for me.
For the case when you have to have the dummy,
Yeah.
how many, so for example, there's 5 jobs and
Yeah.
there's 3 people,
Mm-hmm.
how many lines are you supposed to have for optimal? Do you use 5 or 3?
It depends. You know, the requirement is that we want the line pass zero value in the table. You know, because if you have 2 dummy, you have all 0 for 2, let's say two lines, two horizontal. But when you draw the line, you might draw the line horizontal for these 2. But you might have the remaining 0 in the table, so you can draw after line. But our objective is that we want the minimum number of lines pass 0 value in the table. So it may be 5 or 3, I don't know. We need to see the pattern there, but we need to see the example that you mentioned. But finally, number of lines that you apply have to equal to number of row or column, and then this long. Okay. Look at the example. Are you clear? Or you don't care? You can ask more. Okay. In this case, let's say I'm starting with column reduction first. So now I'm starting with the column reduction first. So I'm going to circle the lowest value for each column. This is the lowest value for each column. And then I use this value subtracting from all the value in this column. So then I have this result. And then I'm just doing the row reduction. Since the first 3 rows, the lowest value is 0, right? The first 3 rows, the lowest value is 0. So then I'm just doing the circle, the lowest value from the row number 4, number 5. And then I'm doing the row reduction. This is the result. Again, everyone pay attention in the screen, and can you draw the line? How many lines did you use? Look at the screen, not doing the handout, because the handout we have solution already, just practice. How many lines?
4.
Yes, it's 4. 4. And I'm sorry, I'm going to show here. So you have 4, right? And then we have 5 column and 5 row. It's less than number of row and column. So it's not optimal. So we need to modify. So then look at the number. So I'm gonna look at the number that's lowest one that is not have the line pass with. So the lowest one is the number 2, right? So we do a circle of 2. And then we can use 2 subtracting from all the value, all the number that is not have the line pass with, and adding at the intersection of the line. So then after you do the first improvement or first modifier, you have this table. Now you need to draw in the line again. So how many lines that you apply? Use minimum number of lines to pass 0 value in table. How many lines? How many lines?
4.
Yes, it's 4.
Yeah, man.
It's 4. So then we not have the optimal yet, right? We modify again. And finally, after we modify, we have this table. And then you draw in the line again. How many lines? That's 5, right? So we done. So you see, the same example. Firstly, I start with row election first. We have no modifier at all. We have optimal solution. Secondly, I try to start with the column first. We modify 2 times. So it doesn't mean that row better than column for the first step. But it can happen that if you choose one side, you can do more. But you choose another side, you have no modifier. So it depends on your luck actually. But for us, this is a deal, as I mentioned, that start with row election first, and then followed by column. Okay, so make it easier for me for marking the score. Any question for assignment? We done. We go home. Okay, we done the assignment. Okay. Now we have. Before we move to do the example assignments, since last week we have 2 examples. So, okay, we finished assignment concept, but I want to stop here and then restart with the transportation problem. So, in order to make the review for you guys as well, from the previous week. Okay, so we're gonna go to let's say. Okay, let's go to possibility.
So can we do dancing tonight? Can we do a tutorial for me? You can do as well.
I can
Do you think it's going to be in the karaoke yet?
I think
It's already
It's
on.
already like in the lunch already.
In the what?
not that's not a hub เรียกว่าอะไร
No, but I mean, it's in the karaoke, like they got the. Ding, 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 ding.
I think already.
we should
You
go
wanna
try
practice?
Yeah, I want to practice.
Just on YouTube, I think you can
Yeah,
find
yeah,
it.
yeah. But I want to make sure it's in the store, like in the actual karaoke bar.
You're gonna go to college.
Okay,
ใช้คารากิ
so we start with this example.
Oh,
We have the transshipping company has 3 warehouses, W1, 2, and 3 to supply demand for 3 distribution center, D1, D2, and D3. The capacity for these 3 warehouses are 1,800 and 1,200 units for W1, W2, and W3 respectively. The demand for D1, D2, and D3 are 700, 1,100, and 1,500 units. So if the following table providing the shipping cost from each warehouse to the distribution center, answer the following question. Okay, question 1, using WAM method to determine the initial solution. Question 2, using the minimum cost. Right, and question 3, based on WAM, using the stepping stone to find the solution. Okay, something like that. So, okay, when you look at the problem, right, first thing you need to do is consider that the problem is maximize or minimization. In this case, it's maximize or minimize. It's tell about the cost, right? So it's minimize, right? It's minimization. It's minimization. So first, check that it's maximize or minimization problem. Secondly, you need to check about total demand and total supply. So in this case, for warehouse, we have 1,000 here, 800, and 1,200. So from the supply side, we have 3,000. But for demand side, D1, we have 700. D2, 1,100. D3, 1,500. So when you combine all the demand, you have 3,300. So demand is not equal to supply side. So we need to have dummy. In this case, demand more than supply. So you're gonna have the dummy growth. So then, in this case, let's say this is D1, D2, D3, and this supply. We have W1, W2, W3, and this one is a dummy. We have demand. This 1,800. So the dummy has to have the capacity 300, right, equal to the difference between demand and supply. And then for dummy is 0, and we duplicate the cost. So now we're gonna do using the worker approximation or WAM method. So we need to find row penalty and column penalty. Right, row and column penalty. If you remember that for the penalty value, we just try to find the difference between the two lowest unit shipping costs, right? For example, the first row, two lowest cost for the first row is 9 and 12, right? 9, 12, so the difference between 9 and 12 is just 3. So this is the first row penalty. The second row, two lowest cost is 11 and 12. So difference is 1. The third row is 10 and 15. Difference is 5. The fourth row is 0 and 0. Difference is 0. For the first column, two lowest cost is 0 and 10. So difference is 10. The second column 0 and 16. So difference is 16. The third column 0 and 9. Difference is 9. Okay. So for the first round of the penalty values, the highest penalty value is 16. So it means that now we're going to consider just the second column. And based on the second column, we're going to choose the cell that have the lowest cost. That will be this cell, right? So then we select the cell, we then install the number. Comparing supply is 300, demand 1,100. So the lower value is 300. So then we deliver 300 to this cell. Once you deliver 300 to this cell, what happens is mean that we use all the capacity of dummy factory. So for the next round, these two cells we will not consider anymore. We will not consider anymore. Then we restart the process again for calculate the penalty value. The first row still 9 and 12, difference is 3. Second row still 11 and 12, difference is 1. The third row still 10 and 5, 10 and 15, difference is 5. The fourth row we don't have it because we finished. The first column is changed to 10 and 11, difference is 1. The second column is 16 and 16, so difference is 0. The third column is 9 and 12, difference is 3. So then you can see that based on the second round of the penalty calculation, the highest penalty value is 5, right? So then we consider just only right now for the third row. For the third row, we're going to choose the cell that has the lowest cost. In this case, is 10, or this cell. So then we select the cell, we're going to deliver the products. So we compare between supply 1,200 and demand 700. So the lower value is 700. So you deliver 700 to this cell. What happened after you deliver 700 to this cell? So it means that the demand of D1 is already fulfilled. So then for the next round, these two cells we will not consider anymore. So the process is we start again, right, for doing the penalty calculation. The first row, the two lowest costs going to change to 9 and 16, so difference is 7. Second row, 12 and 18, difference is 6. Third row, 15 and 16, difference is just 1. The fourth row, we don't have it. First column, we don't have it. And the second column, still 16 and 16, difference is 0. The third column, 9 and 12, difference is 3. So based on the third round, highest penalty is 7. So now we consider the first row only. And based on the first row, the cell that we're gonna choose is the cell that provides the lowest cost, equal to 9, this cell. So we select the cell, then we install deliver the products. So we compare supply side 1,000 and the demand 1,500. So the low one is 1,000, right? So when we deliver 1,000 here, so we can know that the next round, this cell, the V1, V2, we will not consider anymore because we use all the capacity that we have. Then we start the process again. First row, we don't have penalty. Second row, still 12 and 18, difference is 6. Third row, 15 and 16, difference is 1. Fourth row we don't have it. First column we don't have it. Second column is 16 and 18, difference is 2. Third column 12 and 15, difference is 3. So then for the fourth round, the highest penalty is 6 at the second row. So it means that now we consider just only the second row. So we will choose the cell that provides the lowest value. Of course, in this case, is this cell 12. So then we compare supply side 800 and demand side 500. So 800 and 500, you can see that the low one is 500. So we deliver 500. And if you deliver 500 to this cell, then you know that this cell we will not consider, and the rest you can fill in. This one going to be 300 and this one going to be 500. Okay, so this is the RAM technique for generate the initial solution. Okay. The next one is that what happens if we apply the minimum cost to find the initial solution? If you still remember the concept of minimum cost and its name state, right? We select the cell based on the lowest cost. Okay. So in this case, let me duplicate again. So for this one, D1, D2, D3, supply. Okay, for the minimum cost, we will start with the cell that provides the lowest cost. In this case, the lowest cost is 0. We have 3 cells. So you can select any of them. Okay. And let's say that I'm select the first one. Let's say I select the first one. Okay. Minimum cost, we select the cell based on the lowest cost. If you have more than one cell that provides the lowest cost, you can select any of them. Right? So in this case, I have 3 cells to provide the lowest cost that be equal to 0. So I select the first one, cell dummy D1. So I select that cell and then I'm comparing supply and demand. Supply 300, demand 700. Right? So the low one is 300. So we deliver 300 to this one. And we can know that for the next round, these 2 cells, it will not evolve anymore. So now we have like the 9 cells to consider. The process is starting again based on these 9 cells. We can select the cell that provides the lowest cost. In this case, so that provides the lowest cost is this cell, right? 10. So if we select the cell, then we compare supply and demand. Supply side is 1,200.
The lowest cell, isn't it 9?
9. Oh, 9, I'm sorry, thank you. This one, 9. Thank you, 9. So then we compare supply is 1,000 and demand is 1,500, right? So the low one is 1,000. So we deliver 1,000 to this one. Thank you. And then once we deliver 1,000 to D3, we can know that these 2 cells, the D1, W1, D2, we will not consider anymore because we use all the capacity of W1 only. And we have 6 cells to consider. The next lowest one is 10. Comparing supply side 1,200 and demand side 400. we deliver 400 to this set. But we deliver 400, we know that W2 D1 we will not consider anymore because we already fulfilled the demand for D1. Now we have 4 cells remaining. We select cell that provide a cost 12 to be the lowest one, comparing supply 800 and demand 500. So the low one is 500. So if we deliver 500 to this cell, we can know that W3, D3 we will not consider, and the rest we can fill in, right? This one can be 300, this one can be 800. So this is a result of minimum cost in the case that you start with dummy D1. If you start with dummy D2 or dummy D3, you might have the different pattern. But when you calculate the total cost, you're gonna have the minimum same value. But anyway, the question number 3 is said that based on WAM method, using stepping stone method to determine the optimal solution for this problem. So we're gonna go back to using the value from WAM and testing whether or not it reaches optimal solution. This is the result from WAM. So it means that we need to calculate improvement depth, right, from empty cell. So we're gonna find the improvement from cell 1-1, cell 1-2, cell 2-1, cell 3-1. Cell 3-3 and cell 4-3.
อาจารย์คะ700 in the incorrect
Oh,
B1 W3
okay, thank you. ตามมานะ
กันดีนะ
See, this is the problem that I'm saying. I'm not kidding. Sometimes, you spend, let's say, 2 hours already for exam, and then, okay, you can do this problem, and this happens again. Thank you. So, gonna change from cell P1 to cell 3-3 first. Cell 4-1. Okay. Look at cell 1-1. So this is the close part for cell 1-1, right? Sorry. What happened? This is a close part for cell 1-1.
ไม่รู้ I also don't know what the fuck
Right? So this is what part for cell 1. So it means that we're gonna start with this one is 12, right? So we can start with the plus 12 minus 9 plus 12 minus 18 plus 16 minus 10. So you have 3. 7 2 is just square 1 plus 16 minus 9 plus 12 minus 18 have 1. Cell 2 1 is still square plus 11 minus 18 plus 16 minus 10. So we have minus 1. Cell 3 3 plus 15 minus 16 plus 18 minus 12. So you have 5. Cell 4 1 plus 0 minus 0 plus 16 minus 10. You have 6. Cell 4 3 plus 0 minus 0 plus 18 minus 12. You have 6. So in this case, we have the negative 1 minus 1, that's cell 2 1. So it means this is not optimal yet. This is not optimal. We need to modify. We're going to modify cell 2 1, right? We're going to modify cell 2 1. And based on cell 2 1, this is the closed part for cell 2 1, right? Plus 11 here, minus 18, plus 16, minus 7, minus 10. This is called part for cell 2 1. And then we look at the minus signal, right? The lowest value is 300, so we do circle 300 right here. So then we can use this value, add and subtract from the corner at the corner based on the signal. So then let me change to another table a little bit.
You guys are so cute.
Okay, from this we can use 300, right? Plus add positive signal and subtract at the negative signal, and the rest that not involve this cost part still stay the same. So then we're gonna have 1000 still here, 500 still here. For cell W2D1, we're gonna change from 0 to 300. Cell W2D2 change from 300 to 0. Cell W3D2 change from 500 to 800. Cell W3D1 change from 700 to 400. And the rest is going to be the same. Right? So this is the result after you modify. And process is start again. We need to retake every empty cell again. Cell 1 1, cell 1 2, cell 2 2, this case, cell 3 3, cell 4 1, and cell 4 3. So cell 1, right? We can have plus 12 minus 9 plus 12 minus 11. We can have 4. Cell 1, 2. Okay, look at it. This is cell 1, 2. It's like a cross. You can have 4 here. Okay, cell 1, 2. Something like this for cell 1, 2. Okay. So then you're gonna have plus 16 minus 16 plus 10 minus 11 plus 12 minus 9. You're gonna have 2. Cell 2, 2 just square 1, right? Plus 18 minus 16 plus 10 minus 11. Have 1. Cell 3, 3 rectangular. Plus 15 minus 10 plus 11 minus 12. 4. Cell 4, 1 plus 0 minus 0 plus 16 minus 10. We have 6. Cell 4, 3. Then have plus 0 minus 0 plus 16 minus 10 plus 11 minus 12. So you're going to have 5. So that means optimal. Okay, this is the result. Okay. Let me see what next. Okay, you can calculate the total cost by your own, okay? Just using the number of goods that we deliver multiplied with unit cost. So this is the result. Okay, so just have a break, okay? And when you come back, we're gonna go to the last example for transportation, and then you're gonna follow by the example of assignment.